Independent educational content. Views and opinions are entirely my own and do not reflect the official policies or positions of Akamai Technologies. Welcome to this explainer. Today, we're going to get into a comprehensive overview of Akamai's cloud computing. We'll be exploring how they provide these really flexible full-stack compute services, things like VMs, GPUs, Kubernetes, and serverless computing. And it's all designed specifically to build and deploy edge-native, ultra-low latency applications on a global scale. If you've ever had to wrestle with latency-sensitive apps, or those incredibly frustrating egress fees, or just the sheer complexity of multi-cloud architectures, then you already know that the traditional centralized cloud model, well, it just doesn't always cut it anymore.
Just to reiterate what we have right here on the screen, independent educational content. Views and opinions are entirely my own and do not reflect the official policies or positions of Akamai Technologies. My whole goal today is just to give you an objective, totally independent look at how this technology is literally shifting the foundation of our internet infrastructure.
Okay, let's dive into this. Here is our roadmap for today. We're going to start with the distributed cloud advantage, then move right into flexible full-stack compute. After that, we'll look at powering edge-native applications, touch on multi-cloud optimization, and wrap the whole thing up with expert support and services.
Let's start with Section 1, the distributed cloud advantage, or how we are moving data much closer to the user.
And this brilliantly illustrates the big shift we're seeing. For years, the standard cloud model has been super centralized. You build your app in a handful of massive data centers, and your users, well, their data has to travel all the way back to that one central point. It's kind of like a long, painful daily commute to a corporate headquarters just to send a single email. And with things like live video streaming, AI inferencing, and real-time gaming, that long commute introduces latency that absolutely ruins the user experience. So Akamai solves this with a macro-to-micro approach. Over on the left, you've got the core, tens of massive locations with heavy-duty compute. But then, as we move to the right, it spreads out into hundreds of distributed locations. This brings that same robust power right into underserved regional markets. And finally, on the far right, you hit the edge. We're talking thousands of locations, acting almost like remote home offices, pushing lightweight serverless functions directly to the end user. It's essentially a spectrum of compute that lets you choose exactly where your workloads actually need to live.
All right, moving right along to Section 2, flexible full-stack compute and its essential building blocks.
So there's this common misconception out there that edge platforms only handle, lightweight caching or basic front-end routing. But in reality, to build truly powerful applications everywhere, you need real choice. You need flexible, full-stack compute services. And we're talking the whole shebang here. Linux-powered virtual machines, high-performance GPUs for your AI workloads, and managed Kubernetes. You've also got your block and object storage, database as a service, and of course, the essential networking layers like cloud firewalls and private VLANs. The big takeaway for you here is that you absolutely aren't sacrificing standard infrastructure capabilities just to get better geographic distribution. You still have all those core building blocks you need to host mission-critical apps.
Now check out this number, $1 million. That is Akamai's annual infrastructure contribution to the Cloud Native Computing Foundation, or CNCF. So why does that matter to us? Well, it essentially proves that their platform is built for developers by developers, heavily utilizing open standards. By pouring resources into open-source Kubernetes and cloud-native projects, they are putting a huge priority on workload portability. Basically, developers can build apps without that constant, nagging fear of vendor lock-in. It ensures you actually have the flexibility to optimize your multi-cloud architectures safely. Pretty cool, right?
Which brings us nicely to Section 3, powering edge-native applications, also known as the serverless frontier.
Okay, so we have the foundational compute, but how do we actually execute logic right next to the user? Going back to our commute analogy, traditional centralized apps suffer from high latency and just incredibly high egress costs, simply because every single interaction is a long trip. Edge-native apps completely flip this script. By using a mix of cloud and edge computing services, you are shifting the actual data and the decisions way closer to your users. This is a total game changer. It guarantees ultra-low latency, it gives you localized processing, which, by the way, helps a ton with complying with regional data sovereignty laws, and it vastly reduces those dreaded egress costs, simply because the data doesn't have to travel nearly as far. The primary engine driving all of this is called edge workers. Basically, Akamai takes JavaScript engines and deploys them across hundreds of thousands of distributed servers. Think about how caching static content at the edge makes delivery lightning fast, right? Well, edge workers does that for code. It allows for the rapid execution of logic exactly where the user is. This literally eliminates those unneeded, high-latency trips back to the origin server. It's absolutely perfect for things like routing traffic, personalizing content, or managing microservices. You're basically handling your customers' digital experiences as code.
But, logic without data isn't really all that useful, is it? Let's move to and see how this builds upon what we just talked about. That's exactly where Edge KV comes in. It's a distributed key value store built specifically to pair up with Edge workers. It essentially puts the database right next to the serverless application. So now your Edge apps aren't just running logic locally, they're also pulling the necessary data locally. This completely wipes out the need to fetch information from some distant cloud or on-prem database, guaranteeing you the absolute shortest possible round trip from request to response. It's incredibly efficient.
All right, on to Section 4, multi-cloud and traffic optimization, or routing for reliability.
So building a distributed edge-native architecture across multiple cloud providers is without a doubt incredibly powerful, but man, it introduces some immense routing complexity. That's where these intelligent networking solutions step in to tie the whole thing together. You've got the application load balancer cloudlet and global traffic management. And these aren't just your standard load balancers. They're making Layer 3 DNS routing decisions based on real-time internet conditions. They literally route around congestion and outages to deliver 100% availability SLA. Then you've got API acceleration and ION, which use modern protocols like HTTP3 and QUIC to dramatically cut down latency and speed up connection times. Think of these tools as the intelligent glue that makes sure your highly distributed infrastructure actually performs like one cohesive, ultra-fast system.
And finally, we arrive at Section 5, expert support and services, bringing in the human element.
Because let's face it, migrating to a massively distributed platform requires real human expertise. Akamai isn't just tossing you the server keys and saying, hey, good luck out there. They offer several tiers of support to act as a true operational partner. So the crucial point is that you have options. You can grab a technical account manager for proactive, strategic guidance. If you're kind of scratching your head on how to optimize your current setup, you can run compute assessments to uncover hidden cost and performance tweaks. For those truly mission-critical workloads, their enhanced compute support guarantees a 30-minute response time for Severity 1 issues. And if you honestly just want to focus entirely on your core business, their managed cloud operations team will literally take over all the monitoring and management of your infrastructure for you. It's completely up to you to choose the exact level of partnership you need.
As we wrap up, I want to leave you with this one provocative question. Is your current cloud architecture holding your applications back from the edge? We've seen today how a truly distributed cloud platform, spanning from those heavy-duty core VMs and GPUs all the way down to localized serverless edge functions, can genuinely solve some of the most pressing challenges we face with latency, cost, and data governance. So take a hard look at where your workloads are currently sitting and ask yourself, could moving them closer to the user be the key to your next big performance breakthrough? Thanks so much for joining me on this explainer, and I will catch you in the next one.